Hello, welcome to this lecture. Good day to all. Here we are going to discuss about the Unit 3. In Unit 3, we are discussing about the embedded firmware development. The embedded firmware development consists of two parts. One is hardware development and another one is software development. Since we have discussed many things about the hardware development, we are going to see about the software development in this lecture. Software development consists of program modeling. We can write the software in different concepts. The concepts can be modeled by the following models, namely data flow model, concurrent model, sequential model, state machine model, and object oriented model. Whenever we are heading over to design the software for embedded systems, we need to take any of this model for our embedded software development. Depending upon the requirement of the software systems, we may choose any one of these models. On such consequence, we are going to discuss about the sequential model. In the sequential model, the programs are designed to work in a sequential manner. Here you can see the program model consists of functions, 6 functions. The software is being developed to execute the functions F1, F2, F3, F4, F5 and F6 sequentially. First, the program will execute this function F1 and the program this function will return a value, and that return value will be given to the function 2, and the function 2 executes its coding and it returns its value to the function 3, and consequently the sequence of the program will go on up to F6, and this F6 will return the code to the main program. So in this sequential functions or sequential program or sequential software, the functions which are executed sequentially will be having the flow. This sequential flow is being designed that the functions don't have any data dependency problems. If a function have data dependency problem, then the program cannot be designed in sequential manner, because if a program is being designed that function F4 have dependency on F1, then it cannot be executed when the F4 is being preempted to the F1. So these kind of activities cannot be taken into account when we are dealing with the sequential functions. For the sequential function, we may have example of automatic chocolate vending machine. This automatic chocolate vending machine have the functions, namely get user and input, read coins, deliver chocolate, and display thanks. When a child gives a input that I want this chocolate, and after that the child have to give the coin to the machine. The machine reads the coin and it will deliver the chocolate and it will display the thanks. You can see that these functions are sequentially being executed, and each and every functions don't have any dependency on interconnected functions. If I notice that if this sequence is being collapsed, then the system may be collapsed. So while designing the sequential programs and while designing the sequential programmed softwares, we need to see that whether the sequence has been correct, and if the sequence has been whether the sequence has been collapsed by the data dependency or not. Okay. Then the second model is data flow model. Data flow model will take care about the data flow graphs. So data flow graph means we might have studied about the Fourier transform, fast Fourier transform. Fast Fourier transform is a very good example for the data flow graph model. Why it is like that means we know that the Fourier transform have multiple coefficients. In the coefficients, the fundamental coefficient is a naught, and other coefficients may grow up to n. The Fourier transform must have a fundamental component, and it may go up to n. And you can notice that the Fourier transform cannot exist without fundamental. So the fundamental have to be there. So data flow graphs are designed whenever you are having the independent path for the flow of the model. So whenever we are having a software that have the independent path and it does not deal with the any data dependency problems, then we may have the data flow graph model. So you can see an example for this. This process called FAR filter process. We may have some total factors, and that total factors are being supplied with the constants, likewise a0, a1, likewise, and it may be supplied with inputs. So whenever we are having the inputs and the coefficients, we may have the nodes to calculate the total factors, and these nodes are been given as the circles, and these are the nodes which calculate the total factors, and it will be supplied to the summer, and the output will be generated. So whenever we are having the nodes, the software functions are being designed as a nodes. Whenever the software functions are designed as nodes, these functions don't have any data dependencies. If the data dependency problem is being designed with the data flow graph model, then the data flow graph will collapse. So we need not to have such a worrisome situation to deal with this kind of data flow graph model. So whenever we are dealing with the design with the data flow graph model, we need to see that we don't have any data dependencies.